So yesterday we talked about reflections. Today we're going to look at our second of our transformations, and that's rotations. So what is a rotation? A rotation is a transformation that maps all points around a stationary point. Okay, so basically it's going to take everything and just turn it around. We all have seen rotations on wheels. When we rotate things, like let's say we take this sign here and turn it around. If you turn things around a few times, you can actually land some things right back the way they started. We call that rotational symmetry. When an object can be rotated a number of degrees to get the same picture. Okay, so the number of times you can turn that is called the order. So the number of times it happens. Like, let's take this figure here. If I take that figure and we're going to turn it one time, we get the exact same figure back. So that's 1, 2, 3, and 4. So it has an order of 4 because we could turn it 4 times. The H here, we can only turn that. I can leave it there. I can turn it completely around. And there's 1. We get the same picture again. When we look at the circular, I guess that's a recycling symbol, we can turn that one 1, 2, and 3 times and be right back where we are. Order of 1, though, well, that means it has no rotational symmetry. If I turn that symbol, no matter how far around I turn it, I have to go all the way around to get it back to looking like the same picture again. So an order of 1 means no rotational symmetry. And then we can actually figure out the degrees you want to turn it. Like this was order 4. So if I take 360 degrees and divide by 4, I'm going to get 90 degrees. So 90 degrees is the amount you need to turn it one time to get it back to where it is. Order of 2, well, 360 degrees divided by 2. So I need to turn it 180 degrees to get it back. So that's how we can use the order to figure things out. And it's just rotational symmetry. You'll see questions like that periodically about which of these figures has rotational symmetry. Now, that's just a little bit about rotations and looking at how they map to each other. What about the notation? We said that yesterday a little r gave us reflections. A big R gives us rotation. And there's certain things that you have to know about rotations. We need to know what we're rotating around. So sometimes they'll give you a point or some sort of letter. Maybe I'm rotating around point A, maybe I'm rotating around the origin, and then our degrees. So let's say it's 90 degrees. And then, of course, our object. Maybe it's triangle ABC. So this is my center of rotation. And then the degrees is my angle of rotation. And we have to know these things to be able to rotate things, kind of like we needed to know the line of symmetry or the line of reflection for reflections. So the center of rotation is a stationary point about which all other points are moved. The stationary part is very important because it tells you that during a rotation, everything is going to move except that one point. Like when we spun these around, if I put the stationary point in the center, that point doesn't move, but everything else around it is going to move. Okay? If I rotate it in a different way, let's say my stationary point was here, well, then the object would move around that point. Okay, so that's what we mean by the stationary point. The angle of rotation is the number of degrees the object moves. So if I've got, let's say this, we'll call this point A is my stationary point. And if I've got another figure here, let's make a quick triangle, A, B, C. And if I'm going to rotate 90 degrees, well, that means an imaginary line I draw in here, if I make a 90-degree angle with that line, so this angle here is 90 degrees, and as long as these two are the same distance, this will be my new point, because it means that this has now turned 90 degrees in that direction. So that's what we mean by the 90-degree rotational symmetry. Take that, draw another line of the same degrees. Okay, if I wanted to go 70 degrees, let's make up another example. So here's a point P, and I'm going to rotate, let's make a square this time because I'm getting tired of triangles. A, B, C, D. And if I want to rotate around P 90 degrees of A, B, C, D, then what I would do is I'd go, okay, let me draw in this line here, and I'd have to measure a 70-degree angle and get these to be the same length, and there would be my new point, A prime. Okay, B prime, I'd do the same thing. So I would do that with all the points. It's important that we realize positive angle and negative angle. Both of these were positive angles. A positive angle moves in a counterclockwise direction. Okay, so counterclockwise, the opposite direction of a clock's hands. A negative angle moves in a clockwise direction. We've never really experienced negative angles before, and that's why, because when we measure angles, we always measure a positive angle. The direction we measure is what decides if it's positive or negative. Think about a negative number is really going left on the number line, while a positive number is going right on the number line. So that's kind of the same idea. So let's look at some special rules now that we know a little bit about rotations. Just like the reflection rules, we've got some special rules for special times. If we're rotating around the origin, okay, so all of these rules only apply when rotating around the origin. Origin. Okay, in other words, 0, 0. Okay, and you'll notice when they put it here, it just says rotation of 90. If they don't tell me a point, I assume it's the origin. So here's the basic rule. When I rotate 90 degrees, I'm going to take these 2 points, I'm going to swap their order and negate my new first one. So if the point was AB, it's now going to be the opposite of B and A. Now, if I can remember 90 degrees, I can get all the others. Because 180, well, if I went 90 and go another 90, I get that. Okay. Now, a rotation of 180 is interesting because it's also called a reflection through the origin. Okay, so you can actually reflect through a point. So if they told you reflection O, that's going to be a reflection through the origin of point A, B. Well, that's going to give me the point negative A, negative B. Okay, so these things are actually the same thing, and we can make that happen just about any time. Reflection of 270, well, let's see, that was 90, 180, another 90 will be 270. So I'm going to take that, let's get rid of that little weird box that came up here. I'm going to take that and I'm going to move it again. So I'm going to put the negative A is here, and when I move the negative B, it becomes positive. Okay, so let's look at how those apply to positive angles. So those were all the positive angles. Let's look at the negative. Well, if I go 90 degrees in a positive direction, that's like going 270 in a negative direction, because 90 and 270 that's a typo here. That should be 90 and 270 are the same thing. So if I rotate 90 degrees, that's going to be, in this example, instead of negative 4, 7, I swap them. Negative 7, positive 4. If I rotate 270 degrees, so I'm going to take this, swap those. So that's going to be A becomes over here and goes negative, so that makes it a positive 3. The B goes front now, negative 2. So that's how we use those rules. A negative 90 is the same as a positive 270. Think of it like this. Let's take an XY axis and take a point here. If I go 90 degrees in a positive direction, that's going to put me there. If I go 270 in a negative, that's 90, 180, 270. That'll put me in the same place. So positive 90 and negative 270 are the same. Obviously, 180 and negative 180, well, that's going to be the same. And in positive 270 would be the same as negative 90. So when I do a negative 90 rotation of 5, negative 1, rather than try to think of it as negative, just think of it as a positive 270. So that means the A term goes to the second term now and becomes negative. The first term stays where it is. Okay. So if I wanted to look at these, I could say, okay, instead of doing a rotation of 90, it's the same as a rotation of negative 270. A rotation of 80 is also negative 180. And a rotation of 270 is a negative 90. Okay? Keep that in mind. Again, the positive and negative would add up to, the absolute values of them would add up to 180 or 360. So some quick examples. Let's take this point 2p or 2, negative 5, and I want you to rotate all of these. Okay? Give that a shot real quick. All right, so go over our answers. We were at the 2, 5, 90 degrees, so I swap them and make my new first one the opposite. There we go. 270, so I swap them and make the new second one my opposite. So I swap, and that one becomes opposite. Remember, negative 90 is the same as 270, so these will be the exact same answer. 180, I make them both a negative. So negative 2 and then positive 5. There's our reflection around the origin of point P, which we said is the same thing as a 180. So negative 2, positive 5. Okay. Quick challenge problem for you. Take these points F, G, H, and J and rotate them 180 degrees about the origin. What are the coordinates of the new image? So take a second to do that one. Okay, so let's see. We're rotating 180. Rotation of 180 degrees of F, G, H, J. So F prime is going to be 180, so I'll negate both of them. 4, 1. G prime, negate both of them. 2, 5. H prime, negate both of them. Negative 4, positive 2. And J prime, negate them both. And there we go. Okay, so we'll try some more of these in class, and we'll talk about rotating around things other than the origin. That gets a little tricky, so I want to show that up in class. Okay, have a good night.